A beam supports a load varying uniformly from intensity W1 kilonewton per meter at left end to W2 kilonewton per meter at right end as shown. If the reactions RL equal to 6 kilonewton and RR equal to 12 kilonewton, determine the intensity of loading W1 and W2. It is a trapezoidal type of load acting on this beam. This trapezoidal loading can be converted or divided into two parts. Lower will be the rectangular loading and upper will be the triangular loading. This rectangular load is also called as the UDL. It is the uniformly distributed load of intensity W1. Now this uniformly distributed load UDL is converted to point load and its magnitude will be equal to W1 into span 12 meter. It will act at the center of the span. The span is 12 meter, so it will act at half of the 12, that is 6 meter. So taken from left end at 6 meter, our loading is W1 into 12. It is for this rectangular loading. Now upper triangular load, it is a uniformly varying load which intensity is 0 at this end, and at this end the intensity is equal to this height. So this height will be found out by subtracting total W2 minus this W1. So this height of load diagram is W2 minus W1. This is a triangle. So the intensity of this loading varies from 0 to W2 to W1, W2 minus W1. To convert this uniformly varying load to equivalent point load, we will find out area of this load diagram, which is equal to 1 half base is 12 into height W2 to minus W1. On simplification, it becomes 6 W2 minus W1. This uniformly varying load is converted to point load and it acts at the CG of this triangular loading. So CG of this triangular loading is acting at a distance of 1/3 of base from this end, right end. So 1/3 of base is 12, it is equal to 4 meter. So from this end at 4 meter, this intensity W2 minus W1 into 6 will act. Now our aim is to find out value of intensity W1 and W2. Already the reactions RA and RB are given in the question. We'll apply condition of equilibrium. So we'll apply COE. Summation Fy equal to 0. Here no horizontal load, so no need to apply summation Fx equal to 0. Directly we'll apply summation Fy equal to 0. Forces upward are positive, forces downward are negative. So here what are the forces? Plus 6 plus 12, and this is the point load, that is W1 into 12 but acting downward, so minus W1 into 12. This 6 W2 minus W1 is acting downward, so minus 6 into W2 minus W1 equal to 0. So we'll simplify it further. 6 plus 12 minus 12 W1. To expand this bracket, minus 6 W2 minus, and this minus becomes plus 6 W1 equal to 0. So on further simplification, this minus, this plus, it becomes minus 6 W1 minus 6 W2 plus 18 equal to 0. We'll keep it as equation 1. Now we'll take summation moment of all forces about point B equal to 0. Our assumption: clockwise movement positive, anti-clockwise movement negative. This 6 W2 minus W1 is acting at 4 meter from right end, and it is directly passing through this point B. So when you are taking moment of all forces about this point B equal to 0, no need to take moment of this force, it is passing through B. We'll take moment of this W1 into 12. It is acting at distance 2 meter from B. It is going to create anti-clockwise movement. Then this RA or 6 kilonewton. It is acting at distance 5 meter from B. It is going to create clockwise movement about point B equal to 0. On simplification, we get value of W1 which comes to be 1.25 kilonewton per meter. It is load intensity, so its unit will be kilonewton per meter. We'll put in this equation 1. So from 1, on putting value of W1, we get value of W2 which comes to be 1.75. It is also load intensity, so its unit will be kilonewton per meter. Therefore, value of W1 is 1.25 kilonewton per meter, W2 is 1.75 kilonewton per meter.